Okay, today we are taking a look at area and perimeter problems. We are on lesson 13.6 in your book, so we are on page 501. You need to make sure that you have something to write with because you are responsible for following along and working these problems out right along with me. So we know that on Wednesday, we were focused on just perimeter only. We were looking at problems that involved perimeter, and then on Thursday, we looked at problems that involved area. Those two lessons were not in your book. So today, we are looking at problems when you're given the area or the perimeter, and you have to find a missing side length. So again, make sure you're following along. Let's take a look at this first problem. And we're going to work through this together. This problem I call like a triple whammy, so make sure that you're really following along and paying close attention. A can of paint is used to cover all 168 square feet of a wall. So cover all 168 square feet of a wall. I know right away that's talking about area because we're talking about covering a wall. The wall is 8 feet high. So they've given me one of the dimensions, the height of the wall. They've also given me another important piece of information, the total area. It's 168 square feet. Now let's continue reading. Tape is placed along the top, bottom, and sides of the wall. Now that's a little bit different. Tape is placed along the top, bottom, and sides. Well, I don't know about you, but that kind of sounds more like perimeter. If it's going along the sides and the top and bottom and it's tape, it's almost like it's creating like a border or an outline. So I think that's referring more to like perimeter. Let's continue reading. What is the width of the wall? How much tape is needed? Wow. Okay, so we're missing this side length here, but we've been given the total area, and then the question is how much tape is needed to go around this entire wall? Basically, what's this measurement? And then what's this highlighted part? So we're working with area and perimeter. This is pretty tricky. Well, I'm going to take this step by step. So first, I need to find this side length right here. Now, how do I do that? Well, I know that area uses this formula of length multiplied by the width. So I'm going to go ahead and plug in the piece they've given me. They told me that the area was 168 square feet. So that's equal to the length, which is unknown, multiplied by, I guess they called it the height and the width. That's kind of confusing. Let's think of this as like width, and this right here is length. They changed them up in this problem. So the unknown, or the length, multiplied by the width, which is 8. So in our brains, what we need to do is think to ourselves, 8 multiplied by what number gives me 168? Well, I know that 8 can go evenly into 16. 8 times 20 is equal to 160, but I need one more group of 8 because I need 168. So then I'm going to multiply by 21. And 8 times 21, that's equal to 168. I figured out the missing number. That number right here is 21. So what that tells me is that the length of this wall is 21 feet. But what they want to know, remember, not just the length. They also want to know how much tape is needed to go around this wall because they said it goes along the top, the bottom, and both sides. Well, Now we're kind of shifting from area to perimeter. And I know that for perimeter, we add up all four sides. They've also given us this second formula that's like 2 times the length plus 2 times the width. 2 lengths and 2 widths. That makes sense. So 21, then this side would be 21. That means 21 times 2. Plus, then 2 widths. If this side is 8, then this side is 8. 2 times 8. Again, we have 2 sides that are 21 feet and 2 sides that are 8 feet. Some of you like to use this formula. What I've learned is that some of you just like to add up all 4 sides. You're going to get the same answer. 21 plus 21 is going to be 42. And 8 plus 8 is 16. Let's add those together. 2 plus 6, that's 8. 4 plus 1, that's 5. So the perimeter of this figure is 58 what? We're measuring in feet. 58 feet. So the total amount of tape that's needed is going to be 58 feet of tape. The first question they wanted to know, what was that missing length? You solved that right here. 21 feet. Again, kind of a triple whammy, right? First, we had to use the area to find our missing side length. We had to think about what we knew about multiplication to find that missing factor. Then, we had to use the missing side length, plug it into a perimeter formula to find the total perimeter of this wall. Wow. Let's try another one. Hopefully you're following right along. Let's turn the page. The state park shown has a perimeter of 36 miles. All right, so we're looking at this picture right here. First, let's look and see what they've given us. Well, they told us the width. The width of it is 7 miles. If this side is 7 miles, then this side is also 7 miles. But this side right here, length, they're using a cursive L. That part is unknown. But we know that this side is also going to be the same as this side. We know that because we know rectangles have equal length opposite sides. So now let's see what they want to know. The state park has a perimeter of 36 miles, so the distance all the way around is 36. But they want to know, what is the area of the state park? Wow. Well, I'm going to grab a separate sheet of paper to help us solve. So first, we have to find out this missing side length, right? Because that part they haven't given us. So how do we do that? Well, if they told us that the perimeter is 36 miles and they've given us just one side length, the width is 7, well, then I guess we have to use that to help us figure out the missing length. First, we're going to add up the top and the bottom. So 7 plus 7. So far, out of our 36 miles, it's like we've used up 14 miles on the top and the bottom of the state park. Now, that's step 1, add. Step 2, we're going to take that away to figure out how many miles we have left for these two sides. So let's take our total perimeter of 36 and subtract the 14 we've already used. I know that 6 minus 4 is 2 and 3 minus 1 is 2. So we have 22 miles left. Now, it's not just for this side, that's 22 for this side and this side. So in step 3, I have to take that 22 and chop it in half, meaning I have to divide 22 by 2. So how many times will 2 go into 22 without going over? Yep, 11. So the missing side length is 11 miles. Now, if this is 11 miles, right, we chopped it in half, that means that this side is also 11 miles. Now, I like to make sure that I did this part correctly, so I know that perimeter is 36, and I also know perimeter means I add up all 4 sides, so I'm going to make sure. 11 plus 11 is 22, plus 7, 23, 24, 25, 26, 27, 28, 29, plus 7 more, 30, 31, 32, 33, 34, 35, 36. So I did the missing side length correctly. And now, when I look back at the second part of this problem, the area of the state park, now I'm able to solve because I have to know the length and the width to solve for the area. So in the second part of this problem, that's where we're using this formula now for area of length times width. Well, I don't know the area. That's the part I'm solving for. But I do now have a length and a width. The length is 11 and the width is 7. Do we know what 11 times 7 is? Of course we do. The area is equal to 77. 77 what? Well, area means it's covering this whole thing. So we use that special abbreviation, right, of square and then our unit of measurement, which is miles. And sometimes you might see square abbreviated with SQ. So now we know the total area. It is 77 square miles. Whew. Let's try another one. Let's turn the page. Let's look at question number 1. A sandbox is shaped like a rectangle. We've all played in a sandbox before. There's your sandbox. The area is 16 square feet. So they've given us the area. So again, right away, my brain thinks, all right, I'm using this formula to help me solve, and they've told me 16 is equal to. Now let's look. The side lengths are whole numbers. So there's no fraction, there's no decimal. What are the possible dimensions of the sandbox? Meaning, what two numbers could we multiply to equal 16? That's listing all the factors of 16. So we could have a 1 by 16. We could have a 2 by 8. Does 3 go into 16? No. Does 4 go into 16? Yeah, a 4 by 4. Does 5? No. 6? No. 7? No. Now back at 8. So we know all the possible dimensions. Now let's look at the second part of the question. Do all possible dimensions make sense? Well, we're talking about feet. So if we take what we know about a ruler, I'm going to zoom out. If we have a 1 foot by 16 feet, would it make sense to have a sandbox that's just this wide? I don't know about you, but you're not going to be able to do very much in a sandbox that's that wide. So which one would make the most sense? Right, probably going to be this 4 by 4 sandbox right here. A 4 by 4, because it doesn't make sense to have a 1 foot or even 2 by 8 or 2 foot wide sandbox. I wouldn't even be able to fit anywhere close to inside that sandbox. Today you guys are going to apply what you've learned about the missing side length, and you are going to solve problems 6 through 9 on page 503. Then you're going to turn the page and you're going to go over to page 504, and you're doing problems 13, 14, and 15. You do have an exit ticket, and we will meet at 2 o'clock to go over these problems.